All right, today we are looking at the absolute value equations and so on. We might even get into the inequalities today, and we're going to look at this from a different point of view rather than the algebra point of view that we were working with last time. We are going to look at these from a graphical point of view. That is, we're going to use a number line and try to obtain some quick solutions to certain equations and inequalities involving these absolute values. Right? Now, I know we hadn't done inequalities yet, or rather, we haven't done absolute value inequalities, but that's all right. We will see what it means, and then we'll do a formal look using an algebra method. All right, so let's start out again and recall what we mean by the absolute value. So the absolute value, by now you know this by heart, is itself if x is non-negative, or negative x if x is negative. All right, I want to, let's just look at a couple properties, one of which I've mentioned before. We recall that when we were finding the distance between 2 points, if we had the points were A and B on a number line, then we knew that the absolute value of the difference of A and B was equal to the absolute value of the difference between B and A. Right? So we could turn the order, or rather the order of the numbers inside the inside the absolute value did not make a difference. And just recall that if I didn't see this number line from an arithmetic point of view, I could ask, what is the distance between say, what's the distance between, say, negative 11 and negative 3, right? And all I'd have to do is put in negative 11 minus 3, and we would end up that the absolute value here was negative 11 plus 3, absolute value of negative 8, and the absolute value is 8. From a graphical point of view, not that I really want to, I made the numbers a bit larger because I didn't particularly want to go through my numbers on the number line. Negative 6, negative 9, maybe negative 11 is somewhere down here. I wanted to find out what was the distance between these 2 points. Right? And as I mentioned, when we looked at it, it didn't matter if I had started with negative 3 first, right? So it didn't matter. I could likewise have done this as absolute value of negative 3 minus negative 11. The only difference is that inside I'd end up with a positive number, but it's the same thing. Absolute value of 8 equal 8. The distance between these 2 points was 8 units. All right, one of the other other properties of the absolute value that I haven't mentioned before has to do with a product. And so we're going to explore. The rule that I want to talk about is that if I have absolute value of A and B, it is equal to the product of the absolute values of the individual terms. All right, so if we explore, let's look at 4 different examples. We'll just use the numbers 2 and 3. So if I chose negative 2, negative 3, and the absolute value, let's do this in a different color. So if I chose -3, -2, absolute value, I'm asking, is this the same as that? So both are negative. What happens if we make one negative, the other positive? Is this the same? And what happened? Let's change around. Does it matter the order that we have these positive and negative numbers? Remember, the central dot there just means multiply. It's a shortened version of writing across, right? Or times for multiplication. And the final one, both A and B are positive. Would we end up with anything different here? All right, so doesn't matter if I look through here. Absolute value of 6 equals 6. This is the same as 3 times 2, which is 6. So we see that the rule works when both numbers were negative. Again, coming over, absolute value of -6 on the left hand side of the equality is just 6. When I work this part out, I end up with 3 times 2 is 6. So again, didn't matter that one was positive, one was negative. Same thing here. We have the absolute value of -6, which is 6. This is 3 times 2, which is 6. Fine here. Absolute value of +6 is 6. Each of these is just our usual numbers, 3 times 2, which is 6. So everybody works. So we can conclude that this rule is true. All right, just keeping those two rules in mind. That is the distance from the distance formula. Or we can interchange. If we have the difference between 2 points or two terms, we can turn around the order of this when it's inside the absolute value symbol. All right, so as promised, let's start looking at the graphically. What do we mean by absolute value, or solving absolute value equation? All right. One of the first things question that we had done in the last class was solving this equation. The absolute value of x is equal to 3. And recall that the expression, the absolute value, was itself. Now I'm going to pay attention to whether it's non-negative or negative. Right? And what I want to pay attention to is, where is my x? So something is happening about 0 here. Either I'm going to the right of 0 or the left of 0. So if I go on a number line, so this is a graphical interpretation. If I go on a number line and I think about either of, here's my house, this is where I live at 0. So essentially, this part here is telling me, where do I start when I am looking at anything? I'm going to start where my house is, if you wish. And since the absolute value can be thought of as a distance, this is going to tell me that I'm moving a distance of 3. But it doesn't matter if I got up one morning. Let's presume that I'm saying that this equation is describing my jogging pattern in the morning, right? So I'm describing and I'm saying, well, every morning I get up and I run exactly 3 kilometers. So some mornings I'll get up and I will run and I will go to the right 3 units, and so I will end up on a point on my number line which is positive 3. But on another morning I can get up and say I'm going to run exactly 3 kilometers, but this time I go down the street from my house. So I end up at negative 3. So graphically we are looking, where do I start? And that starting point is given from the inequality, right? And how much I move will be the number on the other side of the equation, or the equal sign. Right? As I said, it's only going to be some equations that we are going to be able to solve in this way. So, alright, so let's look at, and of course, you can check this immediately just by doing a mental check. The absolute value of negative 3 is 3, so both solutions work, and I can, on my paper, write the final solution. X is equal to negative 3 or 3. Right? Okay. Let's look at a different one. If instead I said we wanted to go absolute value x minus 2 equal 4. Again, if you look back at yesterday's notes, you will see that we have, these are the exact questions I believe that we had done. Alright, so let's again look at this expression inside the absolute value. So if I do that, let's look at it on the side here. What do I know about it? Well, it can be itself or the negative, but I'm more interested about when would I look, or what number, where will I put my house, if you wish. Okay, so if I look at the inequality, it is x minus 2 is non-negative, or x minus 2 is negative. Let's solve this part. So if we solve it, remember I had done this and said it won't really matter at this stage. Last time, we'll look at it another time, what was the meaning. But you're seeing here that x is greater than or equal to 2, or x is less than 2. So it means that my house is now not at 0, but it's somewhere else. So, right, so my house is somewhere else. Oops, let's start over. Right. Having a little technical difficulty there. So let's put in 0, 1, 2. The point is my house is now at 2. I've run a little short there. Three, 4, 5, 6, 7, 1. Alright, so we all know how to label our lines. And I've put my house, as I said, at the point 2. So here is my house passing through 2. My job will be to look at how far I go. What's the distance? My distance that I'm going to run is 4 units. And as mentioned before, this 4 units could be to the right or could be to the left of my starting place. If I go 4 units to the right, so 4 units, I'll end up at 6. Or if I go 4 units to the left, I'll end up at -2. So I'm claiming that my solution is just a set of x's such that x is equal to -2 or 6. Again, check that solution. You should be, if you again look back at your notes that or the working that you've done, you will see that these are the exact answers that we got yesterday. And you will see, if you just did a mental check, -2 minus 2 is the absolute value of -4, which is 4, so it satisfies the equation. 6 minus 2 is +4, the absolute value of +4 is 4. So we're absolutely sure that these are correct. Alright, so we've gotten those two values. Alright, let's look at one that was a bit problematic. And if we, I may have done this in a different order, but just work with me a bit. If I went back to a problem, I think it was this is +5 = 0. If I again, the aim that we want is we want to see or have the absolute value on one side of the equation and then the number on the other. I already run into a problem because my distance that I'm traveling, this is negative, so I can't go. But let's also look over here. Where did I start? I started, if I'm looking at this as my number line, my house, although it won't really matter, my house would be at -3, right? X plus 3 would be greater than or equal to 0, x plus 3. So the key point is that at x equal to 3, x greater than or equal to -3 or x less than -3. So -3 is a key point. So while this was my starting point, the fact that there is no distance that's negative, right? This can't happen. Then I can't move. I can't run a -5 and -5 kilometers. And so my solution is the empty set. This is an well, we'll just stick to that. This is just what I get. Alright, now let's go back to what I had up here. Remember these two properties that we started the class with. The difference, taking the absolute value of a difference, didn't matter the order. Or if I take a product, then I can break up this product into two parts. So let's apply that to some equations. All right. Okay, a question just came in about the equation that we had, I guess, yesterday, that said absolute value of x plus 10 equal to 2x, even though I would solve for the absolute value. Alright, the fact that there is another term with an unknown on this side, I don't know this distance. So this type of problem cannot be solved. So it can't be done on a number line. Later on, we look at another way of doing it on a plane when we can graph these as functions. But right now, we can't look at this particular question where we're just having an absolute value on one side and a different algebraic expression on the other side. I really want a numerical expression. Okay, so let's move to what my plan was. let's look at something a bit more interesting, where we can actually use some of the rules of our absolute value. So suppose we're given the absolute value of 3 minus 2x is equal to 5. Now, before you get going, let's before you start saying, yes, I'm going to run or go 5 kilometers left and right, it's not quite in the form. What I want is, when I'm interpreting this graphically, I need a coefficient. So here I need a coefficient of 1 for my x's. I can't have a coefficient of 2 or negative 2 as I'm having down here. So let's rewrite this. So using one of the rules, I can write, if I'm using the difference, the absolute value of the difference, we can write it or turn it around. Then we would have nothing changes on the right hand side. I could write this as 2x minus 3. Not that that's a big deal. Alright, the next thing that I can do is I can factor, and in factoring 2, and I get your favorite things, which is a fraction. So let me write that a little lower so that you can clearly see your fraction. All of this is in the absolute value. And then if we now go back and use one of the product rule with our absolute values, okay, then I can rewrite this as the absolute value of 2 times the absolute value of x minus 3 over 2 is equal to 5. So I'm looking a little bit better. Notice that the coefficient of x here is 1. So I'm getting closer to that idea of where do I place my house, how far do I go, and how far do I go running. And so let's continue a bit. So let's simplify. Absolute value of 2 is just 2. X minus 3 over 2. I guarantee that this, once you know the steps, it will become a bit shorter. Let's divide throughout by 2. And in doing that, I get x minus 3 over 2 is equal to 5 over 2. So at this point, I can start. Number 1, looking over here, where will I start? Or put my house, if you wish. And it will be at x equal to 3 over 2. How far will I run or move? The distance that I will move is 5 over 2. Left or right. So in drawing my number line, okay, I know all of you love, I know you hate fractions. So since these are convenient decimals, I'll write the decimal form. And if I start off, so here 0, 1, 2, 3, 4. Put in some numbers, minus 1, minus 2. Okay, so I had started at 1.5. This is where my house is. I think I always normally use a black for my house. Right, so this was 1.5. And we are going to be moving 2.5 units to the right and to the left. So if I go 2.5 units, I end up at 4, right? 0.5 is here, and then 1, 2, so 2.5 units. And if I go 2.5 units to the left, I end up at negative 1. Okay. So my solution will be, my solution is, my solution is set of x's such that x is equal to negative 1 or 4. We can go back and do a quick mental check. So if you check negative 1 in the solution, you will indeed see that it works out. If you put 4 in the solution, 4 times 2 is 8, 3 minus 8, absolute value of negative 5, right? But the absolute value of negative 5 is 5, so both solutions are true, right? And it makes sense. So we can solve any equation, right? So any equation of the form, say, absolute value ax minus b equal to c, we will be trying to factor first, x minus b over a equals c, providing that a, well, whatever a is, we get a positive value, let's say, absolute value x minus b over a, and then x minus, so we will take this equation from one form to the next. Alright, and this will tell me, here's the place on the number line that I start, right, which is b over a, and my movement, given that this, if this is positive, then I will move exactly that amount of units, c over absolute value of a on the left or on the right. Okay. All right. You can practice. We have quite a bit of problems in your handouts for you to practice. So go ahead and do those, and we will talk also about some inequalities. All right, so if we talk about the inequalities, let's go back to our simple absolute value of x equal to 3. What we said was, I'm here, my house is at the 0 mark, and I'm going to be running exactly 3 units. So 3 units, I ended up at positive 3, or I ended up at negative 3. All right. Now let's think about this next idea. So absolute value of x is less than 3. What do you think that means? It means, again, having my house at 0, I got up in the morning and let's make it x is less than or equal to 3. Alright, so I get up one morning and I say, okay, I want to run, my distance that I'm going to run is less than or equal to 3. So some mornings I will make it to 3. Right, and that's great on those mornings that I do, but there are some mornings that maybe I'm just tired, and so I don't quite make it there. I make it to 2.5, 2.9, oh, lazy, come back home. Right, we can do the same thing on the other side. The furthest I would run would have been 3 units down. So ending up at negative 3 on the mornings that I am energetic. But then most of the mornings maybe I'm not energetic, so I don't run that far. And if it happens to be raining, I probably pop up my head out of the door and say, oh, it's raining, I'm just going to go back inside. And so this is all the possibilities that I could have, right? So we are seeing again an inequality, and this inequality is giving us one portion of the line segment. Now, if you remember going back to the combined inequalities, the way that we wrote this as a solution was that x is between -3 and 3 inclusive of those endpoints, right? Or said more formally, x is greater than or equal to -3 and less than or equal to 3. So in here, remember that this is a combined inequality. It really is an and statement. It is a statement -3 is less than or equal to x, and x is less than or equal to 3. Or stated, since we like to tell you in a bit more active voice, for those of you who are in the English majors, that x is greater than or equal to 3. So this is probably how you say it more often. But I'm showing that this region that we have, given by the absolute value of this less than, is really a combined inequality, and we have this and statement. As we go through, providing that if we generalize this, right, we could say, suppose we're given the absolute value of x is less than or equal to some k. Of course, to be meaningful, k has to be a positive number or a non-negative number. So k is non-negative, right? Because it is relating to my distance. Then this can be written either in one step as -k is less than or equal to x, which is less than or equal to k, or in the combined inequality method, where you get x, so one step, sorry, this is a one-step approach, or we get a two-step approach. X is greater than or equal to -k, and x is less than or equal to positive k. Okay, so a two-step, two parts. Okay. All right. Now, if we should, two things. Let's go back to this. So here I have the endpoint being equal to 3. Of course, if we had the endpoints and if I had the absolute value of x is strictly less than 3, then while you would have the same region, those endpoints would not be included. You just have an open circle, and the center here would be shaded. All right. So it's still a combined inequality or compound inequality. So you'd still end up, the easiest way of writing this, however, would be x is greater than -3, x is less than 3. Yeah? Okay. Right. Let's continue again with some more inequality. All right. Taking the same thing, absolute value of x, but this time it's greater than 3, or greater than or equal to 3. Let's do that one first. So again, my house is at 0, and let's see what we're doing. All I'm saying is that I'm running from my house, and I'm going to run 3 or more kilometers, right? So I would, minimum that I would go is 3 kilometers and everything above here, right? So I made it a little bit too short. If I go to the left hand side, I'm going a minimum of 3 or everything to the left of that. Again, these are 2 regions, so we can see from this my solution would be x is less than or equal to -3, or I'm way over the other end, so x is greater than or equal to 3. So we get the combined inequalities, which is using the OR statement. Okay. So in generalizing, the absolute value of x is greater than or equal to k. This will imply that we have an OR statement. We can look at the 2 parts. We can say when x is positive, we get the first inequality, or if it's negative, get the second inequality, where I am replacing my x with negative x. Let's simplify that a bit, but this is a method that you'll be using, which is what I'm pointing out. But typically your textbook will define this as these 2 parts. So your textbook will go from being given the absolute value symbol or expression greater than k, greater than a positive or non-negative number, and then we solve by using the combined inequality with the word OR. Recall that OR was a union. Okay?